In this video, we will explore C++ constructors, which are special methods for initializing objects when they are created. Constructors play a crucial role in setting up the initial state of an object, ensuring that it is ready to use. Constructors are special member functions within a class that initialize objects of that class. They are automatically called when an object is created. Constructors have the same name as the class and do not have a return type, not even void. A class can have multiple constructors with different parameters. This is known as constructor overloading. Let us look at the basic syntax. We have a class called person with private members' name and age. The constructor person takes a string n and int as the parameters and assigns them to the name and age respectively. A default constructor is a constructor that either takes no parameters or provides default values for all its parameters. Consider a class rectangle with private members width and height. The default constructor, rectangle with empty parameter list, initializes both width and height to 0.0. A parameterized constructor is a constructor that accepts parameters to initialize the object's properties. Consider a class circle with private members radius and a constant pi. The parameterized constructor circle takes a double r as a parameter and initializes the radius with it. A constructor initialization list provides a more efficient way to initialize member variables directly in the constructor. Consider a class student with private members' name, ID, and GPA. The constructor student with initialization list takes string n, int I, and double g. After the parameter list, a colon is used, followed by name n, ID I, GPA g, to initialize the respective private members of the class. Constructor overloading means having multiple constructors within a class, each with a different parameter list. This allows objects to be initialized in various ways. The left content shows an example. We have a class called box with private members length, width, and height. It has a default constructor that initializes all members to 0. It also has a single parameter constructor that takes a double side as the parameter and assigns the side to all the members. The right content shows its usage. We can create an empty box by using the default constructor, a cube by specifying the side, and a package by giving the length, width, and height. A copy constructor creates a new object as a copy of an existing object. This is particularly useful when you need to duplicate an object's state. Consider a class point with private members x and y. The regular constructor point takes xval and yval as parameters and initializes the respective private members. The copy constructor takes another point object as a parameter and copies the x and y values to the new object. Delegating constructors, introduced in C++ 11, allow one constructor to call another constructor within the same class. This reduces code duplication and centralizes initialization logic. The left content lists its definition. The right content shows the example. Consider a class player with private members name, health, and XP. It has a main constructor that takes name, health, and XP as parameters. The delegating constructor player takes no parameters. Instead, it uses the main constructor to create a default player named none, with health 100 and 0 experience points. Explicit constructors are used to prevent implicit type conversions. By using the explicit keyword, you ensure that the constructor can only be called with direct initialization, avoiding unintended conversions. Consider a class fraction with private members numerator and denominator. Without the explicit keyword, the first constructor allows implicit conversion from an integer. With the explicit keyword, the second constructor prevents implicit conversion from a double, requiring direct initialization. In summary, C++ constructors are essential for initializing objects. The different types of constructors are default, parameterized, copy, move, and delegating. Best practices include using initialization lists, making single parameter constructors explicit, initializing all member variables, keeping constructors simple, and using delegating constructors to reduce code duplication. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.